it's Miss Lawrence again, and this is the second part of your linear equations lesson. Yesterday we spent some time working with slope-intercept form. After you'd done the notes, we did a lot with graphing and we did a lot of application problems. Today we're going to talk about the second form of the equation, point-slope form. Okay, so when do we use point-slope? What is it and how do we use it? It's just another form of the equation, but this time instead of using the specific point of the y-intercept, we can use any point on the line. It doesn't matter, any x and y that falls on the line, and we also use the slope. When do we use it? Well, we mostly use it for parallel and perpendicular lines. How do we use it? We use it by plugging in a number for this y with a subscript 1, this x with the subscript 1, and this m. The first y and the first x stay as those variables that can change and show the linear relationship between x and y. M is still our slope, and then y1 and x1 become numbers of the point that we use. Okay, so here's an example. Find the equation of the straight line that has a slope m equals 4 and passes through the point -1, -6. So this is just like the example that we used in the first slope-intercept example, except now we're going to use the point-slope form of the equation. So now there's really no calculations that I have to do here. I'm just plugging in something for the slope, for the first y, and for the first x. Okay? So the first y in the equation stays as y, that's my variable. Then it says minus whatever the y is. Well, this would be minus -6 equals whatever m is, or our slope or our m is 4 multiplied by the variable x minus whatever our x is, which is -1. Okay? So now this isn't good, clean mathematics. We've got all these negatives here. So I'm just going to clean it up, because instead of doing minus -6, we can just say plus 6. So y plus 6 is equal to 4 times x. And instead of minus 1, we're going to say plus 1. And that's it. We are done with that problem. Okay? So now this seems very simple and very silly, like why do we even use it? We don't normally use it for these equations. We normally use it when we want to find things that are parallel or perpendicular, and we're going to get to that in a few examples. We're going to do one now where we don't have the slope. Okay? Find the equation of the line that passes through the points -2, 4 and 1, 2. So now I have 2 points, but I don't have the slope. But when I have 2 points, I can find the slope by using the slope formula. So that's exactly what we're going to do. I'm going to erase the shade. Okay, so to find the slope, I take the y's and subtract them, and the x's and subtract them. So I did 2 minus 4 and 1 minus -2, and I end up getting -2/3 as my slope. So now it doesn't matter which point I choose. I can choose either one of these points to write my equation. So I'm just going to pick the first point, -2, 4, and I'm going to use my slope, -2/3. So it's y minus whatever my y is, and my y here happens to be 4. Then it's going to be -2/3 multiplied by x minus whatever my x is, so it's going to be minus -2, but remember, minus is really plus, so plus 2. And that's it, that's our answer. We could have just as easily used the point 1, 2, so let's go ahead and do that. Y minus 2 is equal to -2/3 times x minus 1. Okay? Both of these equations represent the exact same line. Okay, let's move on. So now, when do we use point-slope form? We use it when we want to talk about parallel lines, and parallel lines have the same slope, and it makes sense because they never intersect each other. Perpendicular lines have something called opposite reciprocal slopes. Opposite reciprocal is when I take a fraction and I flip it and I either make it positive or negative. So if I had started with the number 3, its opposite reciprocal would be negative 1/3. The reciprocal of 3 is 1/3. If I start off with positive, its opposite is negative. Okay? If I start off with negative 2/3, the reciprocal of 2/3 is 3/2. If I start with negative, I end with positive. 1/4. The reciprocal of 1/4 is 4. I started off with positive, I end up with negative. Opposite means that if I start with positive, I end with negative. If I start with negative, I end with positive. Okay, reciprocal means we're flipping the fraction. Let's try an example problem. Write an equation of a line that passes through the point 2, 2 and is parallel to the equation y equals x plus 4. They give us the equation so that we can find the slope. If they're parallel, they have the same slope, which means that the slope here, and we know this because of y equals mx plus b, that's what form this is in, the m here is 1, so if the slopes are the same for parallel lines, our new m is 1. Okay? We have the point 2, 2. We can use our m and our point to write the new equation of the line. Y minus whatever the y is equals m, which is 1, times x minus whatever the x is. And that's the answer. Okay, we wrote an equation for a line that passed through the point 2, 2 and was parallel to this line. The reason why it's important that they give us this equation is so that we can find the slope. We know what the new slope is because parallel means same slope. Parallel means same slope. Okay, let's try the next problem. Write an equation for a line that passes through the point 4, -1 and is perpendicular to y equals 1/3 x minus 9. Okay, so now we're perpendicular. Perpendicular means opposite reciprocal slopes. Okay, so if I'm starting with a positive 1/3, I now want to be negative because I'm opposite. And instead of 1/3, I want to be 3. So our new m is -3. Okay, so I have a slope and I have a point. So I'm going to use my formula. Y minus whatever the y is. Since the y is -1, instead of doing minus -1, I'm just doing plus 1 equals -3 times x minus whatever the x is, which is 4. And that is our equation for the line perpendicular to this line and passing through this point. Okay? I will see you tomorrow. Have your notes filled out.